Right, we're just going to do a tiny review of some factoring here at the top because we're going to use factoring to solve some polynomial equations today. So just want to review basic quadratic factoring. So we've got, these are quadratic trinomials. You've got an x squared, you've got it's your quadratic term, linear term that has an x, and you have a constant. That's your plain number, which is the 27. So these guys are of the format ax squared plus bx plus c. And if you guys remember from back when we were working on factoring, we're trying to look for two numbers. We're going to multiply a times c and add to b to help us factor. So on this first question, I got to multiply to get negative 27, and I got to add to get negative 6. Now, the setup for this should just start the two factors, x and x. And the reason for that, if I do x times x, like if we FOIL that back out or draw a box for ourselves, that would give us the x squared. So we're just looking for two numbers that multiply to get negative 27, add to get negative 6. If you get tripped up, I always just try to sit there and write as many factors as I can think of for 27. So you've got 1 and 27, and you've got 3 and 9, and really those are your only options for factors of 27. And so I'm looking at this combination here. One needs to be negative, one needs to be positive. So to get the negative 6, we're going to have to use the 3 and the 9. So to make that negative 6, one of these has to be negative 9, and one has to be positive 3. Now, I'm going to show you on this question only, just as a review. The purpose of doing this, though, we're trying to write this in factored form. This helps us especially if we have an equation, but this is actually equivalent to the question we started out with. If you actually did a FOIL or drew yourself a box, you'd have x times x. That gives you back the x squared. Then you do x times 3, so plus 3x. You do negative 9 times x, so negative 9x. And negative 9 times 3, which is negative 27. So this is the reason for this layout. When I tell you we want to multiply to get c, that number on the end, add to get the number in the middle, because when you multiply negative 9 times 3, that gives you the number on the end, and we want to add to get the number in the middle because we end up combining like terms here, and 3x minus 9x would give you back the 6x. So that's why that's the process for doing that. The answer to the question is what I've got there in the parentheses, the x minus 9 times x plus 3. So that's what we're just going to go ahead and do for the rest of the questions here. All right, this guy is a difference of squares, but you can actually do this. This would be multiply to get negative 16, and there's no b value there, so add to get 0. So the two numbers would be opposites that you want to use there. For 16, you have a couple choices. You've got 1 and 16. You've got 2 and 8, and you've got 4 and 4. But if I need a combination to add up to 0, we're going to have the numbers be opposites, so I'm going to use 4 and negative 4. This is also called a difference of squares. Sorry, I'm going to leave this a little space. One factor should be x minus 4, the other one should be x plus 4, and you can write those in either order. Alright, and then I got one more just to practice with here really quickly. So I'm going to multiply for this one to get 24, add to get negative 14. All right, so to do that, let me go ahead for factors of 24. You got lots of options. 1 and 24, 2 and 12, 3 and 8, 4 and 6. So if I have to ever multiply to get a positive number but add to get a negative number, the only way that can happen is if both numbers are negative. When I start my factors out, they're both going to be just x and x to give me the x squared. And then let's see what combination we're going to use here. We got to use the 2 and the 12. I can make that add up to negative 14 if I use negative 2 and negative 12. So both multiplied together, that's positive 24, but if we add it together, we'd have negative 14x in the middle. Okay, so those are quadratics. We've already done those. What I'm going to add into the mix today, these are quartic. As you can see, quartic, and that just means your highest power of x is x to the fourth. These are actually very, very similar to the questions that we just did. There is one slight difference, other than the exponents are different with how you factor. Okay, so this is x to the fourth minus 6x squared and then minus 27. All right, now, if you're going to do factoring like a quadratic, like we just did above, you have to have an x to the fourth term, you have to have an x squared term, and then you have to have a constant, or I usually just call that a plain number, but the technical answer, or the technical label for that is going to be a constant. Okay, so very similar to what we have above, right? I have x to the fourth, though, instead of x squared, and I have x squared instead of a plain x, but we still have a plain number, which is that negative 27. Okay, so I'm going to think about this really quickly, and I'll show you this on this question. To get x to the fourth, two things I could multiply together would be if I were to do x squared times x squared. And that is really the only difference between factoring an expression that looks like this and factoring the quadratics that we looked at above. This would still work out exactly the same way. We had a negative 9 and a positive 3. Negative 9 times 3 gives you the negative 27. Let me just show you on this question, if I multiply this back out, right? X squared times x squared, I'm going to write it over here, x to the fourth, like if I do my little FOIL, x squared times 3 gives you 3x squared. That's why we want an x squared in the middle. Negative 9 times x squared, negative 9x squared. Negative 9 times 3 is negative 27. We put that back together. 3 minus 9 is going to give us negative 6, but now, because of the exponent change that we made, that's x squared, and you're going to see that matches the original problem. Now, it depends on the question, but this question can actually go a little bit farther, and I don't want you to think this always happens, because it doesn't, but this x squared minus 9, let me back up here, is like this problem we did in part B, where it's a difference of squares. So what I'm looking for that difference, it has to be subtraction, and then if that number is a perfect square, so maybe I'll jot down a couple of the perfect squares so you know what I mean, like 1, 4, 9, 16, 25, these are perfect squares, 36, 49, 64, 81, 100, those kinds of numbers. If you see that, like 9 is one of those numbers, that's called a difference of squares, and so we can break that down like we did in part B above. So I'm going to completely factor this, that's what that says. So that x squared minus 9 can go a little farther. That can go to be x plus 3, x minus 3, and then the other factor, we got to keep the x squared plus 3. That doesn't factor any farther. But the x squared minus 9, that's multiply to get negative 9, but add to get 0. And so I could break that down a little further. So this is what we would call completely factored form. You're not going to run into something like that with a quadratic, but you can run into it if you have a higher power. Okay, so let's look at the one next to it. Similar to the one above, but now this says x to the fourth instead of x squared. So it factors like a difference of squares. It's just going to be, instead of x, we're going to use x squared. And then it's multiply to get negative 16, add to get 0. So 1 is a plus 4, and 1 is a minus 4. Okay, now, never with a plus, but you'll notice there's my list of perfect squares right there. 4's on that list, so this is a difference of squares. So this guy can factor a little bit more. This would be multiply to get negative 4, add to get 0, so I can break that apart. We're going to keep the x squared plus 4. This does not break down any further if this is a plus sign. You can't get anything to work to FOIL out to give you back what you had here. But on this one, we can make this, one of them's x minus 2, one of them's x plus 2. If we multiply that back together, it'll give us the x squared minus 4. Alright, and then we'll just try one more at the bottom. Again, this factors very similarly to the question above. And if you look back to what we did on this one, I'm going to multiply again to get 24, add excuse me, to get negative 14. The only difference is this is going to be an x squared instead of a plain x when I write these numbers in. Just like above, one's a minus 2, one is a minus 12. Now, if you're looking here, neither one of these numbers are perfect squares, so we're not going to go any further. This is just your answer, and it just depends on the question, so you have to pay attention. And if it's not a perfect square there, like 2 and 12, neither one perfect square, can't go any further. All right, now this is what we're going to get into on the back, and you'll see I've got similar problems to what you saw in the front, except for these are going to be equations. So the goal today, once you know how to do the factoring, is to use that skill to actually solve some some of them are quartic. I think actually all of them are quartic today, but we're going to solve some polynomial equations. Okay, mentioned this several times as we've gone through, but I'm just going to write it down here. The number of solutions, or the number of answers you have to one of these equations, is equal to the degree of the polynomial. And if you're like, how do I determine that? This is the highest exponent. So I'll show you that in a question in a second, but it is the highest exponent. Now, after that, it says if the solutions are real, and we actually graphed this equation, they would be where the graph crosses the x-axis, and we call those x-intercepts. These are also known as your zeros, or your roots, or your solutions. But if your answers are real numbers, you could actually see them on the graph of the polynomial, be where it crosses the x-axis. Now, a lot of these have imaginary solutions. So if the solutions are imaginary, you can't see those on the graph. So we'll have to somehow use some kind of algebra to solve for those. And then the last thing says, if all the factors of a polynomial are not linear. I'll give you a tiny example of what, like, linear factor. A linear factor would be something like x plus 5, or I don't know, 4x minus 3, something like that. A linear factor just has its highest power being x. These are really easy for us to just set equal to 0 if we have an equation. We'll do that in some of the problems today. But this says if they're not like that, if they're not linear, you have to be able to solve, you have to at least get them down to quadratic factors. Sorry, I should have given this line a little bit more room. Quadratic factors. So quadratic would be, I'll just give you a tiny example, like x squared plus 4x minus, I'm just making something up. That doesn't factor or anything like that. But quadratic factors, if we have those as part of our solution, as we're trying to break down any kind of a polynomial, we can use the quadratic formula. Possibly we could use completing the square. If we can factor it, then that means we didn't go far enough. But most of the time, if we have a quadratic that doesn't factor any further, we're going to try to use the quadratic formula on that. Okay, so these are the same questions that we just had on the front. So I'm going to put these in factored form really quick, just like we had on the front, exact same question. This is going to start with an x squared. One of these is going to be minus 9, and one is going to be plus 3. Now, if we do our difference of squares, right, this one we could go a little bit further, x plus 3, x minus 3, and then x squared plus 3. This is a linear factor because it's just an x. This is also a linear factor. This is a quadratic factor because it has an x squared. Now, if I want to do the zeros, I got to figure out the number to plug in to make the little set of parentheses 0. So right here, just negative 3. There's one of my solutions. You want to plug that in the original problem check. It'll make it 0. Positive 3 here. Again, if you want to plug that in and check. Hang on one second. I forgot to ask you one question before I started doing that. This question, the highest power of x is 4. So I need to have 4 answers to this question. There should be 4 answers. If this is x to the 4th, you got to have 4 answers. So here's 1, here's 2. and we're going to get 2 answers out of this. Now, I don't just look at that and immediately think to myself, oh, this is what I would plug in for x to make that 0. So if you're ever not sure, just actually take what's inside the parentheses and set it equal to 0, which is what I'm going to do here. So in this case, I would subtract 3. We'd get x squared is equal to negative 3. Then what we would have is a square root to get rid of the x squared. Now, couple things going on in this question. If we introduce a square root into a problem, automatically we should put that plus minus symbol. Now, what that also gets me, this is 2 different answers, positive of this and negative of this. So I've got 1, 2, this will be 3, 4. The other thing I'm going to review just real quickly with you guys, if you have a negative under a square root, 3 is not a perfect square or anything, but I can get rid of that negative by taking an I out in front, and then the 3 remains under the square root. So that means 2 of these answers are real, and then the other 2 answers, which I'm getting right here with the plus and minus, those are imaginary. All right. Now, this is not one we did on the front. So x to the 4th minus 64. If I see an x to the 4th, I'm going to automatically know I'm going to start each of my factors with x squared and x squared. This is an equation, so this is set equal to 0. So we want to see what we would plug in here to make this 0. So this is going to be multiply to get negative 64. Alright guys, sorry, I had a weird problem with my computer just shut off on me because my battery ran out. So if the video is choppy, my fault. Anyway, we're going to multiply to get negative 64, add to get 0. So one of these is positive 8, one of these is negative 8, and neither one of those is a difference of squares. So we're not going to be able to break it down further. I should have, just like the exponent says, 4 answers here. You're going to get 2 answers out of each one of these sets of parentheses. So if x squared plus 8 was 0, that would give us 2 answers. Or our other factor, if x squared minus 8 was 0, that's going to give us our other 2 answers. Now, these are both going to look super similar. Just a little bit of a different first step. This one would be x squared is negative 8. This one would be x squared is positive 8. Now, in both cases, we're going to take a square root. And the one on the left side, we've got a negative. So I'm going to write my plus minus I, radical 8. This one over here would be plus minus just plain square root of 8. So these 2 answers are real. These 2 answers are imaginary, and then we got to do a little work here because we can break down 8 under a square root, right? So this is 4 and 2, 2 and 2. Same thing with the 8 there. So same factor tree. This one's just going to have an I in front of it. So my 2 answers here, we're going to plus or minus. You got a pair of 2's and a 2 left underneath. So with this one, out in front with your I, you're going to have 2I radical 2. That's for this one. And for this guy right here, it would have the same factor tree, but we don't have an I. So my other 2 answers are just going to be plus or minus 2 radical 2. 2 answers here, 2 answers here, so 4 total. These 2 we could actually see on the graph. These 2 we could not. All right, let's see if we can do these guys real quick. So this one, the factored form, if you remember from doing this problem on the front, multiply to get 24, add to get negative 14, but we're starting with an x to the 4th. So we have x squared minus 2 times x squared minus 12. We FOIL that back out. That'll give us the original problem. All right, so if x squared minus 2 was 0, or here if x squared minus 12 was 0. So this one will be real quick. I'm just going to add 2. We're not going to have any imaginary solutions on this one because we're going to take the square root of a positive number. Now, 2 does not break down under a square root with a factor tree or anything, but because we introduced the square root, we do get 2 answers out of this. Could be positive square root of 2 or negative square root of 2. So here's 2 answers. This one, we're going to add 12. So I'm going to do x squared is equal to 12. I've got the square root here. And this one we can make a factor tree for. So 12, I'm going to do 4 and 3, 2 and 2. I'm looking for the pair there. And so we'll be able to pull a 2 out in front. So here x, we took the square root, so you get plus and minus. That automatically gives you 2 answers. I had a pair of 2's and a 3 that was on that factor tree without a partner. So these are my other 2 answers. Positive 2 radical 3, negative 2 radical 3. And then on the last one here, this is the difference of squares. So we're going to multiply to get negative 81, add to get 0. Both of the factors have to start with x squared to give us that x to the 4th. Now, this one, we had this already. This is the difference of squares. So I can break this down, x plus 3, x minus 3. I cannot do that with the x squared plus 9. All right, now I've got, these are just super easy. Just figure out what you'd plug in for x. That's a linear factor, so it just has an x, so we could just figure out what we want to plug in for x. This one would be 3. This one we got to figure out what we want to plug in for x squared. Now, this is not a difference of squares because these two guys are being added, so you can't factor this further. So I'm going to say, okay, x squared plus 9, if that was 0, that's going to give us our answers. So we're going to subtract 9, get x squared equals negative 9. Now, I'm going to take the square root of a negative number here, so that's going to give me an imaginary solution. 9 is a perfect square, so negative 9 is a perfect square in imaginary land. And because we introduced the square root, I get 2 answers out of this because I get the positive and negative version. We just use that plus minus as a shorthand way to write it. And then the square root of negative 9 we would write as plus or minus 3i. So you have 1, 2, 3, 4 answers, which we should have here because we had x to the 4th. Add to get 0. This is a difference of squares. It's just the square root of 64, which is 8.